All right, think about your favorite app or website for a second. Now picture its security like a high-end nightclub. You gotta have a bouncer at the front door, right? Someone checking IDs, making sure nobody's bringing in trouble. Well, in the digital world, that bouncer has a name, input validation, and it's probably the most important line of defense your software has.
But what happens if that bouncer just isn't there? What if every single spot where you can type something in, a search bar, a login form, a comment section, was just a wide-open, unlocked door? That's exactly what an application without proper input validation is. It's basically putting out a welcome mat for trouble.
And this is what that trouble looks like. Now, to you and me, these might look like gibberish, but to an attacker, these are skeleton keys. Something like SQL injection could be used to literally steal an entire database of users. Cross-site scripting can run nasty code on other people's browsers. Every single one of these is designed to trick an application into doing something it was never, ever supposed to do.
Okay, so here's our game plan. First, we're going to expose the unseen threat lurking in bad data. Then we'll meet your first line of defense. After that, we'll see validation in action, look at what happens when things go wrong, and finally, wrap it all up by talking about the security mindset you need to have.
So let's get right into it with the core of the problem, the unseen threat. This is all about how input that looks completely harmless can actually be the very thing that brings a system down.
And you can really draw a straight line from cause to effect here. See, unvalidated input is the direct cause of some of the most catastrophic attacks out there, like SQL injection and cross-site scripting. If you have poor error handling, you're basically leaking secrets about your system. And unsafe memory handling, that can lead to something called a buffer overflow, where an attacker shoves way too much data into a tiny container and can pretty much hijack your whole application. It's the original sin of so many security breaches.
But, of course, there's a solution. So let's talk about your first line of defense. This is where we call in the security team, validation and sanitization.
So first up is input validation itself. This is your gatekeeper, your bouncer. Its job is actually pretty simple. Check the incoming data against a set of rules before you let it in. Does it have the right format? Is it the type of data we expect? Is it too long or too short? If it doesn't check all the boxes, it doesn't get in. End of story.
And then we have its partner, sanitization. Now, this is a little different. Imagine someone gets to the front door, but they've got something suspicious. Sanitization is the act of disarming that item. So instead of just rejecting the input, it modifies it. It strips out the dangerous parts, like weird characters or bits of code, to make the data totally harmless before the application touches it.
So, to put it really simply, validation is a yes or no decision. You're in or you're out. Sanitization is about modification, taking what you're given and cleaning it up to make it safe. You really need both working together for a system to be truly secure.
And when you do this right, the benefits are massive. Proper validation is your #1 shield against all those injection attacks. It protects you from unauthorized access, it stops those nasty memory errors like buffer overflows, and it even saves your server from wasting time and energy processing junk data. So it's not just about security, it's about building an application that's stable and reliable.
Okay, so we know what it is and why we need it. Now for the fun part. How does it actually work? How does our digital bouncer enforce the rules of the club?
Well, there are two fundamental types of checks. First, you've got syntactic validation. This is all about the format. It asks, does the data look right? Is an email address actually in an email format? Is a date formatted correctly? Then you've got semantic validation. This one's a little deeper. It asks, does this data make sense? For instance, if a user picks a start date for a vacation, is that date actually before the end date? You need both for your application's logic to hold up. So where do all these checks happen? There are two main places. Client-side validation happens right there in your web browser. It's super fast, gives you instant feedback, like when a box turns red if you type your email wrong. But, and this is so important, it can be easily bypassed by anyone who knows what they're doing. That's why we have server-side validation. This is the real authoritative check that happens on the application's own server. It's a little slower, sure, but it's secure. It cannot be bypassed.
And the key takeaway here, really, is that you never, ever choose one or the other. You need both. You use client-side for a great user experience, to give people quick feedback, and you use server-side for ironclad security. One is a nice-to-have for your users, the other is completely non-negotiable for your safety.
So how do developers actually write these rules? Well, they've got a few common tools. Regular expressions, or regex, are these super powerful pattern matchers, perfect for checking things like email formats or password complexity. Whitelisting is even simpler. You just create a list of approved inputs, and if it's not on the list, it's rejected. Think of a drop-down menu. And of course, you've got range checks, which just make sure a number, like an age or quantity, is within an acceptable minimum and maximum.
But what happens when, despite all our best efforts, something still goes wrong? This brings us to a really crucial and often overlooked part of security: error handling. Because how you tell a user something went wrong is a security feature all by itself.
See, if your error messages are too detailed, you're basically handing an attacker a blueprint of your system's inner workings. That's called information disclosure. Badly handled errors can also be used to just crash a system, which is a denial of service attack. It's like an attacker flooding our nightclub with so many fake guests that nobody real can get in or out. The real goal is to give helpful, simple feedback to real users without giving away any secrets to an attacker.
And all of this leads us to our final and maybe most important section, the security mindset. This isn't just about code or techniques, it's a fundamental philosophy for how you build secure software.
And this right here is the single most important principle. You cannot trust any data that comes from outside your system. You have to treat every single piece of user input as if it's malicious, as if it's hostile, until you have rigorously proven that it's safe. This is the bedrock of a secure system.
So what are the big takeaways here? Let's call them the golden rules. First, it is always safer to just reject bad data instead of trying to fix it. Trying to filter things is a game of cat and mouse you'll eventually lose. Rejection is a locked door. Second, you have to apply these checks everywhere, at every single input point. Third, your policy should be default deny. That means if something isn't explicitly allowed, it's blocked. And finally, never, ever trust a command sent by a user. Break it down yourself to make sure it's safe.
We've covered a ton of ground, from the attacks themselves to the mindset of defense. So the final question is for you. When you think about the apps you use every single day, is the digital bouncer on duty? Is that front door properly guarded? Because in the world of software security, an unlocked door is an invitation you just can't afford to send out.